My name is Olivier Guérini. I'm working from the ENGIE company. I'm working in the Research and Technology division. I'm in charge of projects in the field of thermochemical conversion of biomass and for biomethane production. So I'm working from 6 years ago in ENGIE, and my first position was in an oil and gas company named Total. I worked there on coordination of different research centers, so I'm still in the research field. So today I've chaired the session on gasification and hydrothermal conversion. So my first point, I was really impressed about the motivation and of all the speakers. Really, there is a strong energy on their presentation. We see that people are really interested about their work. They are really convinced about their contribution for the future of energy transition in US or in Europe. It's really a common vision about their linked to the challenge of today. And I was really surprised about it and really impressed about their contribution. I see a lot of things connected to the economics. Really, the indicators of economics were very present in their presentation. So I think it's a very interesting progress, because now we have some people that are working in research and technology, but are linked to the operational procedures. They are linked to the economic challenge, so they are not only interested by the scientific aspect, but they are trying to have a good contribution to industry. So this is really a common point of all the presentation, and we still have some innovative and breakthrough presentation, more invested on the knowledge and the fundamental science. So it's really interesting with sometimes very good idea, very new idea, and we need some innovation inside this topic. And I see that on two presentations with very interesting ideas, like, for example, to use some byproduct of the process to treat some pollutant inside it. So it's really interesting, because this is in the recycling system, the recycling economy. So before we had some pollutants, this is a cost to treat on a unit, but now it could be a positive benefit on the unit to use that byproduct inside the process. So it is really very good, very amazing ideas on it. I see young people, I see beginners, I see very experienced people. We get people from US with 40 years of experience in projects, so it was very impressive. And we get some beginners with PhD students. They have the same energy. It was really amazing to see that, because after 40 years of work, they're still very motivated about their work. So I think it's very interesting for the beginners to see that future, and I think they are all convinced about contributing to this future and to contributing to the energy transition.
Hi, I'm Dr. David Dayton, RTI International Research Fellow and Director of Biofuels. I had the privilege of being the session chairman for the first afternoon session on pyrolysis. We talked to an international panel, talked about a number of laboratory thermochemical conversion technologies. We had some discussion about techno-economic analyses of those different pathways, as well as some molecular understanding of both catalyst performance, catalyst lifetime, and catalyst activity. Two major takeaways from the session, I think, is there's a lot of activity going on in the laboratory that is being guided by economic analysis for scale-up and ultimate commercialization. Number of different pathways, potential products, as well as fuels. All of these different applications look at niche opportunities for feedstocks and co-processing to come up with economically viable biorefinery concepts. A lot of the challenges are going to be associated with scale-up of these technologies. What often works in the laboratory is difficult to get to work at larger scales, And I think we have some interesting scientific understanding of what's happening in the lab, and we need to translate that to larger scales and commercial applications. I think of the new opportunities, there's a lot of excitement in the number of different pathways that are being explored. People are looking at a whole host of different types of conversion technologies, intermediate production and optimization, as well as different fuels, chemical applications, and various products.
I'm Jonathan Mell. I'm fortunate enough to be the Director of the Bioenergy Technologies Office. That's in Energy Efficiency and Renewable Energy in the Department of Energy. The first talk was looking at very detailed mechanistic aspects to look at deactivation of upgrading catalysts and how to make this practically applied. This has led to the formation of a new company, Versa Renewables. That's quite a culmination or a conclusion that it has gone forward, shown how robust it is, and now a new company is now being rolled out to bring this to market. Then we had a suite of talks looked at a very exciting topic, which is the incorporation of bio-oils co-processing in a FCC unit within a petroleum refinery. There are different ways to do this. We had talks looking at how does one do this? How is the bio-oil stream able to look for positive synergies with the petroleum stream that enters into a fluid catalytic cracker? And this is a terrific step forward through leveraging the existing capital that is in petroleum refineries, which could help biofuels on their ratio of production of annual gallons per capex, and also draw the petroleum industry into being part of the solution. Because, as one of the talks pointed out, the petroleum refinery would then be generating the RINs and take the RIN credit with those that have provided the technology. We looked at detailed mechanistic aspects, or were there any positive synergies between the biomass-derived stream and the petroleum-derived streams? Because there are differences. One's oxygenated heavily, and the other one's less oxygenated, or has an abundance of hydrogen there that you don't see to the same extent with the bioenergy. Then we had talks looking at detailed analytical tools to look at real-time events within reactors for pyrolysis events. This is quite a robust environment, and there were many different imaging and spectroscopic tools that were applied to try and give more of the scientific underpinnings of us looking at how we go forward and optimize the system for the rapid pyrolysis of biomass. And then the last part of our talks, we're trying to pull out or leverage aspects of perhaps prior research in the fossil energy sector. We had talks that were looking at a cleanup system, detailed cleanup system for TARs in syngas. And this might have previously been applied thinking about coal and how we can leverage the breakthroughs that they've had and bring this over for cleaning up a syngas stream for biomass. And another intriguing aspect was, how do we do Fischer-Tropsch with biomass at a scale that is commensurate with biomass? How do we reduce the risk of that? And an intriguing hypothesis was brought forward in the session of what if we were to incorporate a certain amount of natural gas, reduce the risk by having two feed streams, the natural gas and the biomass, bring those together, and again, play on the synergies to arrive at different syngas ratios and look at the different market pressures to reduce volatility and the actual overall price, because there are challenges in that field. So this was quite a diverse session, but there were a lot of really intriguing new ideas that were proposed. What is clear from this session is there are a lot of very animated, energetic, innovative people who are utilizing the new tools and coming up with cutting-edge concepts and pushing the envelope towards the evolution or the nucleation and subsequent evolution of this new bioeconomy.
My name is Lakshmi Narasimhan. I work as General Manager, Center for Novel Catalytic Materials in Shell Technology Center, Bangalore. I chaired the session Pyrolysis 2. My key takeaways of this session are the following. I'm really intrigued with the diversity of papers that were present in this session. It started from all the way to the process reactors up to detailed analysis, up to analytical techniques which characterize the biomass, the pyrolysis oil, and which also helps in determining the reaction pathways. Interesting topic of the session was more to see catalysis pyrolysis picking up and then fast pyrolysis picking up over conventional pyrolysis. And the focus of people were how to stabilize the pyrolysis oil more effectively so that it can become more useful. So having magnesium as a catalyst which can reduce the oxygen content was interesting in the pyrolysis session. Pyrolysis has been really a challenge, right? I mean, the remaining challenge is how do you deal with the TAN, how do you deal with the oxygen, how do you deal with the instability. Still a long way to go with respect to something that we can say commercializable technology, because the dollar value or cost of production of really useful product from pyrolysis is still large and it's not easy to handle it, so it's a nasty stuff. Having said that, people have come a long way to say we can produce now and less oxygenated pyrolysis hydrocarbon compared to what it used to be before. So that's a very good direction to go. Well, the session itself basically threw upon a few things. First of all, the details in which people were trying to get into to understand the kinetics, to understand the molecular dynamics that are going on is interesting, and it gives me a promise that at some point of time people will replicate the nature in saying, hey, can we produce crude oil from biomass in a very cost-effective way and a simple way.
I'm Robert Brown. I'm a faculty member at Iowa State University, where I'm the director of the Bioeconomy Institute. This morning's plenary session had some interesting common themes. They were both about gasification and pyrolysis were the two areas. Interestingly, alkali was an important issue for both gasification and pyrolysis. In the case of gasification, it's a good thing. In the case of pyrolysis, it's a bad thing. I think that's real important for people to keep in mind when they start looking at the feedstock characteristics. In the case of gasification, alkali actually catalytically induces the breakdown of solid carbonaceous materials. In the case of pyrolysis, it actually causes a decomposition to make smaller molecules that are not desirable in bio-oil. So that was a really interesting theme. The other thing was that both gasification and pyrolysis would dearly love to have a system that consisted of a single unit operation, that you put biomass in and you get either a perfectly clean syngas or you got a perfectly upgraded bio-oil. And what we learned this morning is neither case is going to happen. In the case of gasification, there's a large amount of tar produced. This tar in principle could be completely eliminated during the gasification step. In practice, we discovered it was necessary to have multiple unit operations that not only had to remove tar, but had to do it in stages, a heavy tar followed by the removal of a light tar. And ironically, if they could get this catalytic activity of alkali to do what they would like to, it would eliminate that gas cleaning, but we're going to have these multiple steps. In the case of pyrolysis, same type of story, but now we're talking about turning biomass into a liquid. And in both cases, we would like to see that liquid had very little oxygen, which is responsible for the instability of the oil. It turns out the promise had been catalytic pyrolysis could achieve that. In fact, it can do a partial deoxygenation. We still have to do a follow-up upgrading, sometimes multiple upgrading steps, to get it to the desired properties before it could be converted into gasoline and diesel. The challenges that were presented this morning. In the case of gasification, we see a lot of progress being made in being able to take biomass, gasify it, and convert it to biopower. But interestingly, the keynote address just before about the status of bioenergy in Europe talked about the challenges facing biopower. In this case, it's other types of renewable energy, wind and solar, which are able to produce electricity at costs that are dramatically falling. In fact, have gone right past the cost of biopower, making them more competitive. So it turns out the challenge of gasification may be more of a policy, economic issue of could we, instead of producing inexpensive electricity from gasification, instead turn it into liquid fuels or maybe even various commodity chemicals. In case the pyrolysis, the emphasis this morning was on catalytic pyrolysis, the idea we could eliminate some steps that are typically associated with traditional fast pyrolysis, where no catalyst is used to produce the oil. But what we saw that there is still a need to do follow-up hydrotreating to get us to the desired liquid properties for producing gasoline and diesel. So it does indicate we need to be doing more research that compares the traditional pyrolysis to this catalytic pyrolysis and see what the overall cost is going to be for these two pathways. The story isn't finished. We still have to understand which one of these is going to be the desired pathway in terms of lowest cost fuels. In terms of the promise of the bioeconomy, it's real interesting to me. So I'm an old timer in bioenergy. I got engaged in the early 1990s and discovered, though, that the opportunities were fairly limited simply because, in the US at least, much of the emphasis was on what we call cellulosic ethanol, using biological processes to produce fuels and chemicals. Where did that leave somebody that wanted to do thermochemical? Very few opportunities. In my case, I actually went to the state of Iowa that supported our work in what we called thermochemical conversion of biomass. Well, here we are in 2015 and things have really changed. About in the last, it's been less than a decade. I'm going to date it to about 2007. There has been a growth in interest in the thermochemical technology because of its potential to do more than just produce fuels, but it can also produce, as we saw this morning, biopower. It can also produce commodity chemicals. There are a large number of pathways to using thermochemical technologies to contribute to the bioeconomy. And we're also seeing that in many cases it's more cost effective than some of the biological approaches, which are very slow. Fermentation can take days. We saw catalytic pyrolysis was completed in a couple of seconds. And it also has the potential of eliminating some very expensive components of the biological, which is enzymes. Enzymes are extremely expensive. In the case of thermochemical technology, sometimes all you need is heat. Sometimes you need various catalysts, which was one of the focuses of this morning's session. So I see there's a lot of promise in the bioeconomy for these thermochemical technologies. That is the whole point of this conference.
Hello, my name is Bob Baldwin. I'm a principal scientist at the National Renewable Energy Laboratory. I've been there since 2008. Prior to that, I was at the Colorado School of Mines on the chemical engineering faculty for over 30 years. So I'm sort of in my second career. I've been asked to comment on what 2 or 3 of the most important takeaways were from the session I chaired this morning. So let me try to do that. I'll give you my opinion, which might not be shared by some of my colleagues who were in the session, but I'll certainly try to give you my perspective on what I heard this morning. First and foremost, there's a lot of interesting work going on all around the world, and biomass technology is alive and well, and we're making some real progress, but there's lots of progress still that has to be made before we can reach commercial success. Jonathan Mayle pointed out a very important thing, I think, and that is we need some success stories. Our fledgling industry doesn't have a lot of success stories to talk about at the moment. BTG being perhaps the one bright light in what is otherwise not a very bright scenario in terms of commercial success stories. But lots of promise, lots of interesting work going on, lots of new technologies being developed, some really revolutionary things going on in the world, and very, very hopeful that the next time we have this meeting that we'll see more commercial success stories like BTG being rolled out for everybody to look at. Major takeaways from this morning's session, I think, are 2, at least in my mind, and they really are what are the impediments to commercialization or commercial success of biomass conversion, bioenergy conversion. And I think there are 2. First is cost, and the second is risk. So let me talk just briefly about what I heard and what I think I heard about both of those issues this morning. First of all, cost. How do we reduce cost? Well, certainly there are efficiencies that we can come up with in terms of better ways of doing what we're currently doing. We can learn a lot from talking to each other. That's what meetings like this are all about. Certainly process intensification, where we're looking at taking 2 or 3 unit operations and trying to combine them to make things more streamlined. All good ideas. But the fact of the matter is, making fungible hydrocarbon biofuels is not easy from biomass. It's a very difficult chore, and it's costly as a result of that. So we need to look for other, more clever ways, perhaps, of reducing the cost. And one of the concepts really is an old concept that's been around for a long time, and that's to go back to the biorefinery model, where we have many outputs from a biomass biorefinery, fuels being only one of them. Perhaps the major output, perhaps not the major output, but other products from biomass that take advantage of the fact that biomass has a lot of oxygen in it, and we don't necessarily have to work quite so hard to take all the oxygen out. We leave some of the oxygen in, and we can find certainly good examples of molecules in the fuel pool where oxygen might be tolerated. In gasoline, certainly we know that oxygen can be a very good thing to blend in. Certain types of oxygen are well accepted in the gasoline pool. Diesel, not sure, the jury is out on that. There's a lot of work being done on that at the moment. Jet fuel, no. We know that that's something that really can't be, we can't mess around with the fuel pool when we talk about jet fuel. But gasoline and diesel, I think there's a lot of opportunities. We need to work with the refiners to understand what their restrictions and concerns are about different kinds of oxygen. And we need to really understand what these oxygen moieties are. What are the species that are going to be put into the fuel pool? If we dial back a little bit on the severity and we leave some oxygen in our fuel products, what types of oxygen, where are they going to wind up in the refinery, where are they going to wind up in the fuels, and what positive and negative aspects does this have? So that, along with making co-products, high-value co-products, I think gives us some additional levers to twist in the biorefinery model, so that perhaps the economics can be improved and the cost of manufacturing biofuels can be brought down. The other big one is risk. How do we deal with risk? We'd love to have, at the next time we meet in 2 years, we'd love to have ExxonMobil and Chevron and BP standing on stage saying, we're doing this now, this is a commercial technology, we're embracing biomass as a feedstock for our refineries, but the risk is high, and we all know that, and that's the reason, one of the primary reasons, that industry is not standing on stage and saying those things, at least not today. So how do we reduce risk? And that's an issue that I don't have an answer for, but that's something that I think we need to be talking with our industrial friends about. What are the big risk factors? What are the barriers? How do we get over these barriers so that we can de-risk the new technologies that we're developing, so that we can see them being rolled out in the commercial world? So hopefully in 2 years we'll have made a lot of progress on this notion of de-risking technology. The government, I think, has a big role to play in de-risking technology. Again, Jonathan Mayle mentioned that in his keynote address this morning. And hopefully that will be an increasingly important factor as we make progress in the future. So very encouraged about what's going on, a great conference, and thanks for the opportunity to make some comments.
My name is Lars Waldheim. I'm a chemical engineer. I live in Sweden. I'm an independent consultant. I was chairing the gasification session on the Tuesday afternoon on the TCBiomass 2015. It was an interesting session, around 50 people in the audience and 8 presentations. And I found some things kind of particularly interesting, and one of the things was the difference in the character of biocoal from thermal treatment in liquid phase and the pyrolysis and gasification chars. I haven't quite realized this. This is maybe a kind of engineer's attitude to it, but it was an eye-opener to me, and seeing these processes coming on, that these differences exist. And as far as the R&D questions, I think we're back to the old thing, which is gas cleaning, and some ash and inorganic problems in the gasifier. But still we are struggling how to deal with the tar in order to be able to do all the other elements of gas cleaning which is required, in particular for more advanced applications like synthesis of SNG, etc. And I think what I've sort of learned from this presentation, that I've been in this biomass and gasification business for about 3 decades. And in the beginning there were quite few people around doing it, and it was like a small global family. But the thing which is happening now, in spite of difficulties with oil prices, etc., and all the policy problems which were discussed in the plenary session this morning, that there are still young people coming into this business and doing research and presenting new results. So I think there's good hope that we can launch gasification as part of the bioeconomy. And one thing which I found particularly interesting and have to think more about is the use of other renewable energy sources like solar and wind in conjunction with gasification as a supporting hydrogen source to keep the carbon inside the fuel and not send it out as CO2, which means that the carbon impact of biomass and renewable energy in the fuel sector could be increased by at least a factor of 2, according to 1%. And this is probably something that could be very interesting, as it's being discussed that we will see surplus renewable electricity for extended periods, at least in certain parts of Europe and other places. So I think that was one of the things that I would want to take with me and think further about and see how it could be integrated in other work I do at the moment.
I'm Doug Elliott, a laboratory fellow at the Pacific Northwest National Lab. I've been there about 41 years, following and working in the bioenergy development field. Interesting to see it grow and fade and grow back again, and it has been a treat to be part of this conference this year to hear about all the latest developments in the field. My role this afternoon has been the chairman of the upgrading and pretreatment session. It's been very interesting to hear some of the latest developments related to liquid fuel products coming out of the thermochemical conversion of biomass. We heard both hydrotreating of pyrolysis oils as well as hydrothermal liquefaction biocrude products. Interesting to see the similarities between those products and valuable products that can be produced. The analysis is moving forward. We're learning many more details by the more definitive research and analysis of these products. Pleased to see that the products can be qualified as fuels, meeting ASTM standards for gasoline and diesel fuels, as shown by the participants here at the conference. Clearly, the analysis of these products is a key issue. We're learning more all the time about the definitive nature, the definitive structures within these products, and this is key both for understanding the crude oil product coming out of the initial conversion, but also can be applied to how we then upgrade them into the finished and final products. Well, clearly these presentations have shown us that we're making good progress. The attempts to upgrade the oil have now led to good longer-term operation. The details of the analysis that validate the standards that the fuels that are being produced can meet the standards of a commercial product. What we need to do is move forward into scale-up of these processes now.
Hello, my name is Stan Fry, and I chaired the last session of the pyrolysis section. I'm from UOP Honeywell, and I'm an R&D fellow at that, and I work across a pretty broad range of technologies there, including renewables. This afternoon's session I thought was very encouraging and interesting in that it got into a lot of reality, very frank discussions actually, across a broad range of things that I really haven't seen much in renewable conferences really until now. Maybe that's an indication of the maturity of where we're at overall. I saw discussions about contaminants in feedstocks and how to address them and what they might do to catalysts later on, especially the trace materials that often are ignored because people are looking at broad yield structures and possibilities of what could happen. Well, if it does happen, what about the rest of the feedstock and what's it going to do to the process units? What's it going to do to the product quality? Finally, a discussion addressing logistics. A major issue with biomass, of course, is moving biomass to a point where you process it. The reason that petroleum has such a great advantage over biomass is because it's such a huge energy density right out of the source. Biomass has that difficulty where it's entropically challenged because it's just kind of spread out all over the landscape and you've got to gather it up. Once you gather it up, now how far do you want to transport this fluffy material? Great presentations on analyses of what densification does for overall costs, what it does. I think we could probably do more work in what it does for life cycle analysis. Certainly discussions about breakpoints. How far away can you go before you have a different processing strategy to allow an economic and life cycle reasonable solution to the problem. We saw discussions of new pyrolysis technologies, which is very exciting, combining circulating fluidized beds in riser reactors. Certainly there's a lot of discussion about in situ and ex situ catalytic pyrolysis, and that is going to continue onward. Again, how does that kind of technology integrate with the overall chain of what is going to finally become the big picture? How are we going from field to the gas tank? The whole broad span of it. In part of that, had discussions at the conference when we start to pre-treat biomass to get it more transportable. There are regulatory barriers right now, still in law and policy, that make accounting for that and giving incentives for those kind of transitions over what we've traditionally said is a biorenewable fuel plant. Here's your feed in, and there's a finished product out. That is likely not the best scenario when it comes to overall economics over the long haul, nor is it the best scenario probably for overall greenhouse gas reduction or social impact or environmental impact. Probably stepwise conversion somewhere along the way is the way that is going to be most scientifically reasonable and most economically reasonable. And I believe that the regulations need to catch up with that fact, hopefully sooner than later. Otherwise, it's probably going to stymie real innovation that drives down costs. Finally, regarding costs, a really frank conversation at the end of the day about capital cost estimates and the reality of what we see coming out and the danger of cost overruns. I was very encouraged with that, being in a company that consistently does capital cost estimates for the petroleum industry. We are constantly challenged by the petroleum industry about exactly what was said at this conference. And we have a very large team at our company to specifically do capital cost estimates to the best accuracy possible. We need to be putting that same kind of rigor and reality into capital cost estimates for biorenewables. And it was discussed afterwards that maybe we should have standardization of techniques of doing those cost estimates, and I think that's very valid. We discussed how modularization can improve improve the risk scenario for any new project because it reduces cost to a certain fraction of maybe what a mega facility would look like, and being modularized, if you're looking at in-house or in a shop fabrication versus field fabrication, the cost uncertainties are greatly reduced. So I think it was a very encouraging afternoon overall because of the focus on reality, because we were getting very close to actually making something happen.